In the following circle, chord AB is perpendicular to chord CD. These lengths are given. The question is, what is the radius of the circle? I thank a viewer from Edmonton, Canada for suggesting this problem. It originates in a junior math contest around the 1970s. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So how can we solve this problem? I'm going to present two different ways. One method will use classical geometry, and another will use coordinate geometry. So let's get started with method 1. Consider a circle that has two perpendicular chords. Let's label these four lengths as W, X, Y, and Z. What's the radius of the circle? There's a great video on the channel Maths by Amaya about perpendicular chords and radius. Here's the remarkable formula. 4 times the radius squared is equal to the sum of the squares of these four values. Wow! So let's use this formula to solve our problem. We're given 3 of the lengths. W is equal to 2, X is equal to 6, and Z is equal to 3. What's the value of Y? We can solve for Y using the power of a point or the intersecting chords theorem. W times X is equal to Y times Z. We can then substitute in values and solve that Y is equal to 4. So we now have all 4 values, and we can simply substitute them into our formula and solve for the value of the radius. And we'll get the square root of 65 all over 2, which is approximately 4.031. Wow, that's a very direct way to solve this problem. But what if you didn't know this formula? Well, let's actually prove why it works. The key principle is that a circle's center is always along the perpendicular bisector of a chord. So let's start out with the horizontal chord and draw its perpendicular bisector. Let's label some of these lengths. Now half of the chord will be W plus X all over 2. The remaining segment will be X minus this, and that works out to be the quantity X minus W all over 2. Now let's draw the perpendicular bisector of this vertical chord. It'll be something like this. So now let's label some points. First of all, this will be the center of the circle because it's where the two perpendicular bisectors meet. Next, we want to figure out this length, and that'll be half of the chord. So it'll be Y plus Z all over 2. We now have the necessary ingredients to solve for the radius. All we need is one more trick. To prove this, we're going to draw this triangle right here, and it'll be a right triangle because these two chords are perpendicular to each other. Furthermore, notice that the hypotenuse goes from the center of the circle to the circumference of the circle. So its distance will be the radius of the circle. Now we use the Pythagorean theorem to get that the square of the hypotenuse is equal to the summed squares of its legs. We can then expand and simplify this formula. Now we use the power of a point formula that Wx is equal to Yz, so we notice these two terms cancel out. So we then get that r squared is equal to the sum of these squares all over 4. All we need to do is multiply by 4 and we get the formula. And that concludes the proof. So now let's go on to the second method that uses coordinate geometry. This is actually the way that I solved the problem because I didn't know that earlier formula. Here's how I solved it. I set up a coordinate system where the two chords intersect at the point 0, 0. We'll label the center of the circle as the point P, Q. Let's now label the points A, B, and D. A will be equal to -2, 0, B will be equal to 6, 0, and D will be equal to 0, -3. We're now going to use these points and the equation for a circle to get some equations. So from point A, we're going to get the equation that -2 minus P, the quantity squared, plus Q squared is equal to R squared. We can then set up an equation for the point B. Now using these two equations, imagine subtracting them. We'll cancel out the q squared and the r squared terms. We can then very quickly solve that p is equal to 2. We can then substitute this back into one of the equations, so we get another equation that 4 squared plus q squared is equal to r squared. We now get an equation using point D. We again use that p is equal to 2 to simplify our equation. Now using these two equations, we can subtract one from the other and we'll eliminate the r squared term. This will allow us to solve that q is equal to 0.5. We can then substitute that into our first equation and we'll get 4 squared plus 0.5 squared is equal to r squared. We can then solve that r is equal to the square root of 65 all over 2, which is approximately 4.031. So this is another way that you could have solved for the answer, and I think both methods are pretty cool.